Now let's go to next title. EMF induced in a coil rotating in a uniform magnetic field. As the coil rotates in a magnetic field, the flux linked with the coil changes and an EMF is induced in it. Suppose a rectangular coil PQRS, named over here PQRS, that is initially placed in a magnetic field, horizontal magnetic field, with its plane vertical, such that its plane is perpendicular to the magnetic field. Now, the coil rotates anticlockwise with angular velocity omega and rotates by angle theta in time t. Now check the normal in first case, or the initial condition, is along the x-axis and plane is along the y-axis. But as the coil rotates, the normal rotates by the same angle as the coil, and now it makes angle theta with the x-axis. From the definition, we know that omega is equal to theta upon t. This implies theta is equal to omega t. Because of this rotation, the flux linked with the coil changes. The flux linked with the coil at any instant of time is given by phi is equal to B dot A. B dot A is B A cos theta, and theta is omega t over here. So the rate of change of flux linked with the coil is obtained by differentiating equation 2, which gives dA omega sin omega t. Derivative of cos omega t is minus sin omega t. Now, according to Faraday's law, induced EMF is equal to N d phi by dt. When we substitute the values, we get E is equal to N B A omega sin omega t. Let me share. Now, the maximum value of that induced EMF is at theta is equal to 90 degree, and E maximum is denoted by E naught as value NBA omega. That maximum value is called peak value or amplitude of induced EMF. Now we can write equation 3 in terms of amplitude as E is equal to E naught sin omega t. If R is the total resistance involved in the circuit, then we can write expression for induced current as I is equal to E by R E naught sin omega t upon R. It can be written as I is equal to I naught sin omega t. That I naught is peak value of current or current amplitude. Equation 4 and 5 show that both induced EMF and current in a rotating coil are sinusoidal quantities. So the variation of current and induced EMF in a coil rotating in magnetic field is shown in figure below. They are sine wave. They have same phase. The induced EMF varies between plus E naught and minus E naught, and induced current varies between plus I naught and minus I naught. We have considered only one way. So complete wavelength means total time period T. Half wavelength complete means time period T by 2. 1/4 of wavelength completed means 1/4 of time period. Here 3/4 of wavelength completed, so this time period is 3T by 4. For each quarter of wavelength, there is phase change of pi by 2. So phase of this point is pi by 2. This point 2 pi by 2, this point 3 pi by 2, and this point 4 pi by 2 or 2 pi. Okay.